are Team Genesis. For our senior design project at NYiT, we built an autonomous object tracking UAV.
UAV stands for Unmanned Aerial Vehicle. This means our aircraft was piloted without a human being inside.
My name is Tracy and I was team leader. I was in charge of the flight software for the quadcopter.
My name is Carmine and I was in charge of designing and building our quadcopter.
Hi, my name is Chris. I was mainly in charge of the interface software for object tracking.
My name is Beulah. I was mainly in posting documents and the object tracking software.
My name is Tommy, and I'm mainly in charge of the software for object tracking.
The quadcopter frame is made from aluminum and consists of 4 arms. There are 4 motors, and each motor is connected to an individual electronic speed controller. The electronic speed controller are then connected to the wireless shield and a power harness, which is connected to an 11.1 volt battery. A programmed Arduino Uno board is connected to the AeroQuad V 1.9 shield. The AeroQuad V 1.9 shield contains a gyroscope and an accelerometer. All electronic speed controllers and receiver signals are connected to the AeroQuad shield. This video shows a test flight of our quadcopter outside on a windy day. For the real-time object tracking, we are using a Motorola Droid X phone and an app called DroidCam. This app allows video streaming between the phone and our computer through a Wi-Fi connection. The video is received and processed by our program written in MATLAB for object tracking. The program was designed to track red objects. As you can see, when the object is on the right side of the screen, there is an output which represents the direction of the quadcopter and the X and Y coordinates it should be moving. These directions change as the object moves. We began to implement the autonomous object tracking portion with our quadcopter to obtain autonomous flight. In this video, we can see a ground test of how autonomous flight will be achieved by using autonomous object tracking process. The object tracking code designed in MATLAB will produce a direction that will act as an input to the motors and results in different motor or motors to move accordingly. The moving motors would be the motors that would have to change speeds and power the quadcopter if it was to fly in that direction. For example, if the object was found on the right, a signal to motor 4 will be sent and would move the quadcopter to the right. Many UAVs currently hold the functionality of remote sensing. Most sensors used on UAVs detect electromagnetic waves. With our quadcopter, we can stream video at random distances as long as we have Wi-Fi connection. UAVs in production can be used for commercial aerial surveillance purposes. With sensors having the capability of even detecting the smallest movements, our quadcopter will be able to monitor wildfire mappings, home security, anti-piracy operations, livestock monitoring, and even policing the roads. Unmanned UAVs have been used in research and development in a lot of countries. Our quadcopter can be used in universities and research facilities to teach students about response imaging and remote sensing. It can also be used for agricultural maintenance, observing crop growth, detecting diseases, and vegetation stress. Since the early 1900s, UAVs have been used in war and combat. Our quadcopter can allow a view of real-time events in places that may be dangerous to send human beings, such as detecting things in underground facilities and illegal trafficking. We, Team Genesis, truly believe that our autonomous object tracking quadcopter will make a difference in a world with advancing technologies.